Okay, welcome back. In this video, we will talk about functions. We had already a video about functions in a nutshell, but now we will deepen our knowledge and get all the necessary informations in order to be able to understand how functions work and to define functions. So first of all, let's just reiterate what we had already. So functions are basically code containers which communicate with the other code parts via a well-defined interface. And the example which we had on that slide is that basically if I have a code which at some point needs to calculate the faculty of 5, then or the factorial of 5, then basically it can call a certain function, pass the number 5 to this function. This function can do whatever it wants inside, but at the end it should return the factorial of 5, and basically during while this function is executed, the main code should just stop, right? So the main code stops, the code execution starts, and then when the code execution of the function has ended, then it returns to the main code, and the main code can continue operations, right? So that was the basic definition of the function. Why should we use functions? Of course, first of all, it helps us a lot to partition our problem in small steps. So if we have a big problem, we can just decompose it in small logical steps, and we can pack every logical step in a function, and basically each of them can be written independently, developed independently, and very, very important, we will talk about later in later lectures, they can also be tested independently, right? And of course, whenever you need the factorial of something, then you can just call your factorial function, so you don't have to code the same algorithm again and again. So it helps you basically to reuse your code. And of course, if the functions names are chosen in a nice way, then it makes your even code descriptive, because instead of having a complicated algorithm, you just have the word factorial, and you know, okay, here the factorial will be calculated. Very important that the internals of the functions are not visible from outside, so that means you can hide all the implementation details and even change all the implementation details without affecting all the codes which are just calling your function. Okay, so let's have a look how the function is really defined in Python. You have first here the def keyword as a first thing. Then you have the name of the function, which is called here factorial. Then you have to specify the arguments of the function. So basically the parameters or the arguments the function takes from the outside world. And then you also are able, or you can also tell the function which kind of argument it should expect. So here I'm expecting an integer. I'm even specifying that I will return an integer. This is so-called type annotations and typings. This is optional, and we will talk about that later more in detail. And then because the function is a block, there you have, of course, here again the column operator. Then the next one you have is the documentation, the docstring, of course, where you are documenting what the first of all what the function does. Then you are specifying which arguments the function expects, and if the function returns something, then you are specifying what the function returns. And for the documentation of the function, you should use some established format. I would suggest to use the Google Docstring format, which is a very readable one, very user-friendly one, and most of the tools understand, but you can choose also another one. The main thing is use something which is established, and there are tools for that to extract it. Then you have the function code, basically, in the function body, which implements your algorithm. And if the function should return a certain value to the caller, then you have a return statement with the expression which should be evaluated and returned to the caller. So how do you call the function? Basically, it's very simple. You are just saying a certain variable equal, and then you are just calling the function by typing the name of the function, and then parentheses here, the two parentheses, you are putting in just the input quantity, the argument, which will be here used for n within the function body. And if you store the return value in the variable a, then if you print a, then you will get exactly what the function returned for that value. Okay, there is something you should understand with respect of variables when you are using functions, and the difference between local and global variables. So the local variables are all the variables which you define within the function, and the good thing is they are invisible outside, and whenever you call the function, they are created newly with new content, and they are also destroyed whenever you exit the function. So for example, if we are calling as before our factorial function, if you remember, our factorial function had an internal value which was called result. If you try to access the value of the variable result, you would get basically a name error because this variable outside of the function doesn't exist. And that's a nice thing because basically you can rename your variable or change everything within the function without affecting the outside world. There are also so-called global variables. Those are variables which are declared outside of the functions in the same module as the function or in the same notebook. About modules we will talk in the next video a bit. They are visible in the function, but they cannot by default not modified, so they are read-only. Typical example, if you have some constants which are universal constants and you want to use it in multiple functions, like, I don't know, the conversion factor from Bohr to angstrom, then you can define it outside of the function, and then basically within the function you can access this value. But by default you cannot within the function modify this value, which is quite good. There are a way of doing that by declaring them global within the function, but please don't do that. Try to avoid it. Usually there is no reason, or there are very few scenarios where there are good reasons to change that. So basically just think about variables defined in your notebook or in your module as a sort of global constants, right? And you should actually do not really, when we are developing bigger codes with the help of modules, which I will talk in the next video, basically there is no real reason to have anything declared here in the module space apart of constants. Okay, now let's have a look on the function return value. So basically, as I already said, it's the return statement, and the return value is optional. And if there is no return statement, the function will nevertheless return, but then the return value would be a special value which is called none. So think about the function, for example, a greeting function which does nothing else, just really prints out a greeting with a given name. The name is given as the first argument and the only argument of the function. And this function, there's nothing really meaningful which this function should return. It just executes a certain task, and that's the only thing. You could nevertheless try to store the return value of the function in a variable like here, in val equal the value what you get from print greeting. You would see the string on the screen coming from this print statement, but this is not the value with the function return, because if you print the value which is stored in the variable val, then you get just none, and none. This is a special value indicating that the function doesn't return anything meaningful. So the question is then, do I have to store it at all? And no, basically the return value can be stored in Python, but doesn't have to be, so it's optional. And if you just don't process it, it will be discarded. What does it mean? That if you are just calling print greeting without any assignment here on the left hand side, you just call the function, then basically the function will be executed, and whatever this function was returning, it will be just discarded, which you usually would only discard if the function is anyway returning none. But you can in theory also discard any type of return value. So none is something which you should discuss a little bit more about. So what is this none object? It's a special immutable, so-called immutable object in Python, so you cannot change it. And this is usually used to signalize missing or invalid entities, right? So that's the usual role. If you remember, we had the .get method of the dictionary in order to get a key with a certain default value, and we were specifying explicitly what the default value should be if the key is not found. But in theory, you can just leave away the default value, and then if the key is not found and the key, the string C is not in the dictionary, so we will get the default value, and the default value is, if you try this small script in your Python environment and print the item variable, then you use the default value is none. So none is used to signalize that, okay, this key was not present in the dictionary. So how can you check whether something, some variable which you stored is the same as none? And for that, you should call the so-called is operator. So basically, if you want to check if a certain item, if the variable item contains the special object none, then you should use exactly this kind of Python programming. So if item is none. If you want to check whether something is not none, then either you can just negate this entire expression here, or, and this is much nicer and much readable, you can use the is not operator, which is basically say if item is not none, that means if the object which is stored in the variable item is not none, then the according block will be executed. So basically this is the is not operator which you should use if you want to check if something is not none. Very important thing to note that basically, you know, as we discussed already in Python, every expression can be evaluated as a Boolean expression, and none will be also evaluated as false. But this is the same as 0. So be a little bit careful if you are, for example, using the get method. As this example here, you can try it in your Python environment. If you are getting the key A from the dictionary, the key A actually exists, right? So it will be Python will give you as a return value the corresponding value 0. The corresponding value 0 is then stored in item. And now if you are just writing if not item and basically do something, then you will not know whether this not item is fulfilled because you get back none or because you get back 0, because both of them, both 0 and none, both of them are evaluating to false. So basically you cannot distinguish between whether you got the default value none or the number 0. So therefore, whenever you want to check something, whether it's none or not none, then please use the is and is none operator. Otherwise, maybe it's an interesting thing to discuss about comparison, whether equal, how equal and is relate to each other. And basically the big difference is that equal is checking equality, whether values are equal, and is checking identity, whether two objects are the same in Python. You remember we had this discussion with mutable type and assignment, and here you can have a look at the example. I am defining a list here, L1 with two objects, and then I'm defining a second list, L2, which is L1. And as you remember, we discussed that L1 equal 1, 2 only means that L1 points to the object in memory which contains the where the list 1, 2 is stored. And if I have an assignment L2 is equal L1, then L2 also points to the same object in memory. And if you are checking whether L1 is L2, of course they are, and you can even check whether L1, L2 is pointing to the same object in memory, and this is what you can check with the is operator, and also in this case that would be is accordingly. Now if you make a copy of the list of L1, as you remember, we can just copy the list by applying the list as an argument of a list function. Then L2 will be a separate copy of L1. They are not the same, they are not pointing to the same object in memory, but two different objects with the same content. And then if you are checking on equality, you would still get that L1 and L2 are equal. But if you are checking whether they are identical, whether they are the same object, then that's not the same anymore. So is and is not are checking for identity, and equal and unequal are checking for equality. Now let's go back to the function calls on the functions and have a look how we call functions. And as we already discussed before, you can call a function by entering the name of the function and adding the opening and closing parentheses. Even if the function has no arguments, like this function hello world here, you have to specify the opening and closing parentheses in order to call the function, right? That's very important. If you are just writing the name of the function, then basically you get the so-called the expression. What you get is a so-called function object. You could even store this in a variable like here. So if you say func is equal hello world, then you are not storing the result of the hello world function, because there are no parentheses here, but you are storing basically the hello world object. And if you have a look at that, what it is, then you say, okay, this is actually a function. And you can actually, because func is not a function, basically the hello world function, you can even use the variable name func and applying the function call operator with the opening and closing parentheses in order to call that. So basically the main message is never forget the parentheses if you really want to call the function itself. How can I pass parameters? Basically there are two ways of passing parameters. The one way is the so-called passing positional arguments based on their position. And let's have a look at this very simple function when I am basically specifying 3 different arguments which the function can accept. And if I want to call this function my func, then yeah, I have here the opening parenthesis, and then 3 different entries, the integer number 12, the list will contain 9 and 2, and the string hello. Then basically, depending on the position, they will associate it with the according parameter in the function. So 12 will be associated with arg1 here. Then the list second here in the call will be associated with the second argument defined in the function, and so on, right? So it's quite logical. You have to be careful that, or just know that passing parameter is like a variable assignment. So basically passing 12 here and taking it here as arg1 is equivalent to say arg1 is equal to 12. What does it mean for us? We have to watch out for side effects if you have mutable types, as we discussed already before. So basically, if I am passing something which is mutable and I am manipulating this mutable thing inside, then the effect will be also seen outside. So basically here I have a list with the entries 1, 2, 3, 4. I'm calling this function with this list. Here I'm manipulating the 0th element of the list, and then basically that means that after finishing the function, the changes can be seen in the original list, because of course, as we said, assignment of mutable types, then L will show to the same location in the memory to which also my list shows, where the list 1, 2, 3, 4 is stored. So watch out also for side effects here if passing mutable data types. Then there are the so-called keyword arguments, where basically you are passing something by name, or on the function side and definition side, you have something by name, and you are specifying default values. So what does it mean? So let's have a look. I have this function. I have a position argument arg1, and I have a second argument where I say, okay, should be equal none. That means if the function arg2 had not been specified, then assume that it has the value none. And I have a third argument where again I am specifying a default value. If the third argument is not specified, let's assume that its content is the string default, right? So I can, why is it good? Because then I can call my function with just a single argument only, and the second argument will be assumed to be none, and the third argument would be assumed to be the string default. What happens if I'm calling this function with 2 arguments? The first argument is passed accordingly, the second argument is passed accordingly, the third argument is missing, and therefore it will be assumed to have the default value, the string default. I can even pass the arguments in arbitrary order. So for example, if I don't want to specify the second argument, but I want explicitly specify the third argument, then I can basically say, okay, I am passing the position argument, this I always have to pass, and then I'm skipping the second argument, it will be none, and then the third argument should be the string myStr, and then you see then the third argument would be myStr, and the second argument would have just a default value which was specified to be none for the second argument. And this is the only way to specify the third argument without specifying the second one. So basically you can use it in the call by providing the name of the argument. That's usually works quite nicely. There are just a hint here that there are so-called keyword only and position only arguments as well. We will talk about that also in a sec. It's important that, of course, the keyword arguments must be specified after all positional arguments in the call as well as in the definition. So basically, it doesn't work that you are specifying a keyword argument for some arbitrary keyword and then you try to pass something by position. And the same on the definition side. You cannot define a keyword argument on the definition side and then define a positional argument. That doesn't work because Python wouldn't know how to associate the arguments in the call with the parameters in the function. The one thing we should be watch out for if you are using default values like we discussed is if you are using mutable types, and you should never do what you see here. Just specify a default value, a mutable type as default value. Why? Just type it in your Python environment what you see here, and then try to call this function and store the result in the variable res, and then just print out the content of the variable res, and you will see that this is basically the empty list, as it should be, because you call the function without argument and the default argument was the empty list. So far so good, it works like expected. Now let's manipulate this list res by appending just the number 1 to that. So if in your Python environment, if you are now printing out the value of res, you will get basically a list here with the value 1. Now let's call the function again without any arguments. So if the function is called without any arguments, we would expect that then the default argument is set to the empty list. So even res2 should contain the empty list, but it does not. As you see, res2 contains the list which contains a number 1. So basically the function doesn't work as expected. So therefore you should never do that. And why is that? Because in Python, by default, these default arguments are only created once. And of course, if you create the empty list once, and whenever you call the function, it refers to the same empty list, then if you also associate the variable res with this empty list and manipulate it, then basically all other instances would be attached to that. So the main message is, do not ever use mutable types as default arguments. Okay. But then how should we do things if we need indeed the empty list as a default argument? Then the way of doing that is setting the default value to none. So basically none is immutable, so there are no problems. And within the function, we are just having a one-line statement which says, if the argument is none, then set the value of result to the empty list, otherwise use the argument itself. And then it would work as expected, right? If I'm just calling the function the first time, the result is an empty list. I can manipulate this empty list which I got back, and then it has, of course, some value as appended. But if I'm trying to call the function again, like the function good example again, I get again the empty list back as expected. Okay. So for the advanced among you, I would like to also to mention some other features of functions, because you might also see that, especially if you are reading the documentation of NumPy or SciPy, where it's heavily used, but also you can use that maybe in some scenarios. And those are the so-called keyword only and positional only arguments, and the two operators, the slash operator and the star operator in function argument definitions. So what does it mean if you see those things in a function definition? When you see the division operator as a separate argument, it means that all the arguments before the division operator are position only, so they cannot refer to by name. And if you see the star operator somewhere, then that means that all the arguments after that can only be called, when you call them, only be called as a keyword arguments by name, so they cannot be used as positional arguments. So what does it mean? Let's have a look on the positional arguments first. So let's assume that we have the function definition above. If I now try to call my function and I'm trying to pass for argument 1 the value by name, then I would get a type error, because argument 1 is before, here is before the slash argument, the division argument, and therefore it cannot be used as called as a keyword argument with its name in it. So it must be used as a position argument. But what would be the typical use case? It would be the typical use case would be functions where you have arguments where the name is not really meaningful. So that's no semantic leaning. Think about a function like min. So if you would write your own min function, which you actually should not, but if you would write your own min function, whether you call the first and the second argument of min x or y or a b or a1 and a2 or whatever, it doesn't really matter. It has no semantic meaning. And therefore it's better to say, okay, it's a positional only argument. So basically when you specify two numbers, you have to put them here in the right position, but you cannot give them use their name. And the good thing is, if you later want to change those names in your implementation, because you only allowed the caller to call your function with positional arguments only without any names, any name changes, if you change x to a and y to b, nothing would change for the caller. The other extreme is the keyword only argument. Here we have set arg3 a keyword only argument because it appears after the star argument in the function definition. So if you try to pass the first argument by position, then you will get again a type error, because this is not a position but a keyword only argument. When would you use that feature? You would use feature if you have many optional arguments of a functions which do not have really a logical order, right? So for example, if you have a function which implements some plotting and then you can pass the data, it makes a lot of sense to have it as a position argument. But whether you specify the color first and then the style or the other order, it doesn't really matter. And also for the readability, when you call these functions, it's much more readable if you force the people to use the argument name, so you know that blue or whatever string is there is meant to be the color of the plot of the plotted lines, for example. Okay, and the last thing, the advanced feature I want to tell you about function definitions or argument definitions, that you can also define functions which have an arbitrary number of arguments, either an arbitrary number of position arguments or an arbitrary number of keyword arguments. So try out this function in your Python environment, type that just in, and then you will see that the star here, what is the star for? The star gives you basically tells Python, okay, collect all further position arguments. I have one position argument here, but any position arguments beyond that, it can be 0 arguments, 1, 2, how many doesn't matter. If there are any arguments after arg1, any position arguments, then basically put them into a tuple called args. The same here with keyword arguments. I have defined here explicitly a keyword arguments. If there are any further keyword arguments specified, doesn't matter which name, they should be put in a dictionary called KW-args. How does it work? Let's make a function call. If you typed everything in, just call this function here. So my func and here with 1, 2, 3, so with 3 position arguments, and let's also call it with 3 keyword arguments. So the first one is KW-arg1, but then we are also specifying 2 more keyword arguments which are not specified up there. Let's call them KW-arg2 and KW-arg3. And if you call this function, you see that, okay, the first argument was a position argument, it's associated with arg1. Then we had 2 more arguments, which are additional arguments, which were called by the star args. So basically args, under the name args, you have basically a tuple with the element of those additional arguments, right? So this here I'm just printed args, and this is a tuple with 2 elements with those 2 things. The same for the keyword arguments. Here the first keyword arguments was specified here, and okay, it got the value 11. And then I have specified 2 more keyword arguments here, as you can see, and basically those 2 more keyword arguments were put into the dictionary in the KW-args dictionary. Why? Because I was specifying here up in the function definition KW-args as with double star, which means collect all the keywords arguments. So with that way you can collect the arguments, position arguments or keyword arguments more than one, if you don't know how many you have at the beginning. Okay. Good. The only thing is, of course, which you should remember, that if you have such a collective argument which collect things, then it must be the last one of its type. So basically, after you specify in the function header star args, you cannot have any position arguments anymore defined, because of course it collects all of them. And the same here, if you are specifying double star KW-args, then you cannot have, this must be the last argument. You cannot have any more keyword arguments beyond that, because it would collect all the keywords argument in the call which are there at that point. Good. And the last thing we would like to talk about, I would like to talk about here, is the so-called type hints, which we had a look already at the first or second slide. And these type hints are basically you can help Python and the reader of your code to give hints about what kind of type a certain variable or argument is supposed to be. It's very important to know that these type hints are not used during downtime, so it will not affect how your Python behaves or with which speed your Python script is executed, right? So the type hints are basically only for you and for the tools you are applying on your source code. So Python nevertheless remain dynamically typed. So basically a type of a variable can change during execution, which it should not. So it's a good practice not to do that, but nevertheless Python, even if you use type hints, remain dynamically typed. What does it mean, and how can we do that? If you want to, for example, declare a variable n to the value 5, and you want to say this n should be an integer in my program, then you can make a colon and then int. And then you say, okay, this is an n with an integer with the value 5. Or similarly, if you have some variable, let's call it radius, and you want to say it should be a float variable and the initial value should be 49.3, right? And it would mean that, okay, this is you could in theory leave away this type hinting if you don't want, but here we were making a type hinting and telling Python we are expecting that this variable radius is always a floating variable. Similarly in functions, what we have seen already at the beginning of this video. So if you want to say that the first position argument should be an integer, or you have a keyword argument and you want to say this should be integer, it has of course a default value because it's a keyword argument, but still I can say if the user specifies a value for that, it should be an integer. And I can even make a type hinting about the return type of the routine, which is of course this arrow, so dash greater int, which means that this function is expected to return an integer. Now type that into your Python framework, Jupyter Lab, or in your Python editor, and then call this function and print out the value what you get if you are calling this function with the values 1 and 2.8. And actually this should not work in theory because 2.8 is not an integer, but we say that the second argument of this function should be an integer. But as I told you, during runtime this information is not used, so Python will happily run and basically print you the result, accepting a floating point number for the second argument. Okay, now you could ask yourself, okay, but why the hell should I use all those type hints? And the reason for that is because there are many tools, type checker tools, which are available, or your graphical interactive development environments might provide those tools which are checking those matching arguments during development. So basically it's not during the run, but during development, right? Okay, so what does it mean? If you have installed, for example, the MyPy tool and the program which I have here is stored in the test.py file, if I'm running MyPy on the test.py file, it would immediately give me an error message and say that in the line 6, which is exactly this line here, which is the run with the incorrect argument call, the second argument is incompatible type of float, but it was expecting actually to having a type int. So basically you get an error. Or if you are using a graphical editor, for example, here I'm using Visual Studio Code, but you could use Python or PyCharm, it's the same. They all offer this functionality. When you write this line, it already has this red wriggles, below your number, and if you go with a cursor over that, it even tells you that there is a type mismatch in the call. So basically, that means that you can correct it during development, so that means that you won't have any problems later. And this is a very helpful thing to detect many errors which can happen to you in Python. In other programming languages you would get those error messages during compilation. Python is dynamically typed and interpreted, therefore there is no compilation step, but nevertheless you can get this information if you are using the right development environment. Okay, and with that, basically, we are finishing the functions. If you want to, about type hints, sorry, just one more thing before we really finish. If you want to have more information about type hints, please look up this website. This contains all the information you need to write nice type hints, also for more complicated data structures. In Python, I won't cover the details here because they are very nicely described here. With that, we finished already the function part.